if you consider a periodic signal xt, let's say Fourier series with respect to t naught is ak. Xt is a periodic signal, Fourier series coefficients are ak. What is the average power of the signal? Average power of signal xt. How to find the average power of a periodic signal? Is it this? Is it the average power of the signal xt? That is the definition of average power, isn't it?
Yes, sir.
And we are taking mode because we generally consider xt complex valued signals. Otherwise, we could have taken simply x square t, but we take the mode because this is the definition for complex valued signals. Okay. Now, can I write this as 1 upon t naught integration over t naught xt into x star t dt?
Yes, sir.
Yes. That is the average power of the signal. Okay. Now, xt Fourier series coefficients are ak. Now, if you consider this integral, 1 by t naught integration over t naught, I am taking xt x star t what is this integral? Our objective is to find this. Okay, I am considering this integral multiplying with e to the power j k omega naught t. What is this? Is it is it Fourier series analysis equation? If you do this integration, what will you get? What will you get? What is Fourier series analysis equation? If xt Fourier series coefficients are ak, how to get this ak? Is it 1 upon t naught integration over t naught xt e to the power minus j k omega naught t dt? Is it?
Yes, sir.
That is the Fourier series analysis equation. Now tell me what will you get if you do this integration? Fourier series coefficients of which signal? This is the Fourier series coefficients of xt. Here I am replacing xt with xt into x star t. So will you get the Fourier series coefficients of xt into x star t if you do this integration?
Yes, sir.
So if I am writing this xt into x star t, is it a periodic signal? If xt is periodic with period t naught, can we find a Fourier series representation with respect to period t naught? And let me denote it as pk. Is it? Then how to find this bk? Is it this integral?
Yes, sir.
Yes. So we can say that pk is 1 upon t naught integration over t naught xt x star t e to the power minus j k omega naught t dt, isn't it? Now what is our objective? Our objective is to find this integral. That is the average power of the signal. Now can you tell me what is the relation between this bk and ak? Which property you have to use? It is the multiplication property. Multiplication property says that if xt, what is the Fourier series coefficients of x star t? If xt Fourier series coefficients are, it is a star minus k. So using the multiplication property, can we get bk is equal to what? Bk is equal to
AK convolution.
ak convolution a star minus k. Is it that? Now tell me, what is this integral? What is the average power of the signal? How is it related with bk? Average power is this. How is it related with this bk?
K0, sir.
Is it b0? b0 is the average power of that signal. So can we say that b0 is ak convolution a star minus k at k is equal to 0? And don't write like it is a0 convolution a. This is wrong. Okay, it is a convolution because it is convolution of two sequences, and you have to find the value of that convolution at k is equal to 0. Is it?
Yes, sir.
Yes. So what is that? What is this convolution of these two ak convolution a star k, a star minus k? Can we write this as this convolution? I am writing it here. Bk is ak convolution a star minus k. So what is the expression? Summation over m a m, then what? Is it a star minus k minus m? Is it that? This convolution, I am writing it in the summation form. This convolution. Is it this?
Yes, sir.
Yes. This is bk, isn't it? bk is ak convolution a star minus k. Now tell me, what is b0? b0 is what? In terms of this, put k is equal to 0 here. Will you get this? A star what? Into
M.
a star m. So is it same as this?
Yes, sir.
Okay. So that is the property. What we have shown here is B naught is summation, this summation, and B naught is the average power of the signal. So the property is that if xt Fourier series coefficient ak, then the average power is, we can find the average power of the signal as is it? This is what we proved here. The
Yes, sir.
average power of the signal is this. We can, if you know the Fourier series coefficients, we can find the average power of the signal. And this is a very important property. This is known as the Parseval's theorem. Okay. Parseval's theorem that relates the, for Fourier series representation, that relates the average power of the signal with its Fourier series coefficients. Okay, that is Parseval's theorem, and it is also in physics, it is also known as the Rayleigh's identity. But we call it Parseval's theorem. Okay, so let me write it here. If xt Fourier series with respect to period t naught is ak, then the Parseval's theorem says that the average power of the signal, this is the average power of the signal, that is equal to, this is the Parseval's theorem. Now, can you tell me what is the significance of this term? It is summation of, what is the significance of this? On the left hand side, this is the average power of the signal. This is average power of xt. What is this term? For that, we have to look at the Fourier series representation. if we consider the signal xt this is the Fourier series representation, ak e to the power j k omega naught t. Okay, it is linear combination of this complex exponentials, harmonically related complex exponentials. Now, what is the contribution of the kth harmonic in this xt? Is it ak into e to the power j k omega naught t? Can we say that this is the contribution of kth harmonic in that summation? Is it? Fourier series representation, you are writing it has a linear combination of harmonically related complex exponential. And this is the kth harmonic. And in this summation, the contribution of that kth harmonic is ak into e to the power j k omega naught t. Do you agree with that? So what I'm saying is, if you have a signal xt, this is the Fourier series synthesis equation. It is sum of linear combination. It is a linear combination of complex exponential. I am considering the kth. Let's say the mth term. I am taking the mth term when k is m. Is it the term in the summation?
Yes, sir.
Yes. This is the mth harmonic, contribution of the mth harmonic. Is it a periodic signal? Is it
Yes,
a?
sir.
It is a periodic signal. What is the average power of that signal? How to find the average power? Is it the average power of that mth harmonic contribution by that mth harmonic? Is it that?
Yes, sir.
What is this? Can we simplify this?
Yes, sir.
What?
Mod AM square.
It is mod am square. Okay. So what does this mean? The Parseval's theorem. On the left hand side, we have the average power of the signal. So the Parseval's theorem says that the average power of the signal is equal to sum of the average powers of what?
All the harmonics.
The contribution by the harmonics, isn't it? That is the Parseval's theorem. Okay, that is the significance of this equation. Here, this is the mod ak square. That is the contribution by contribution of the kth harmonic in that summation. Okay, so that is the Parseval's theorem. We'll